Welcome to our talk on broadcast email prioritization by cross-domain recommendation. As one of the 2.6 billion email users in the world, have you ever got annoyed by those irrelevant emails? According to New York Times, email overloading is causing a trillion-level economic loss. This challenge has resulted in a thriving research field, personalized email prioritization. Personalized email prioritization tries to predict importance labels for emails. One of the most famous applications is the priority inbox of Gmail, which highlights every important email with a yellow marker. However, an important type of email has been overlooked in the past, that is, broadcast email. A broadcast email is an email sent to a group of receivers, like the notification emails we receive from the university or the promo emails we get from an e-commerce website. For broadcast mailing lists, there usually only exists one sender, the mailing list admin, and the receiver may get hundreds of different emails with various importance labels. Moreover, users tend to provide only very limited types of feedbacks for broadcast emails. These characteristics makes traditional email prioritization methods fail. On the other hand, broadcast email also brings us a big opportunity. That is, to adapt a collaborative filtering approach for email prioritization. Since broadcast email are sent to many users, others' feedback can be very helpful in predicting the priority for a target user. For example, if we know Bob shared similar preference with Susan, Ben, and Ken based on their previous email viewing patterns, and for a new email, if Susan, Ben, and Ken all think it as important, Bob is highly likely to consider it as important too. However, one key challenge is that each email waiting for prioritization is completely cold. That's to say, no view email behavior has been observed since it hasn't been sent to anyone. To solve this challenge, we first send the email to a small number of carefully selected users, wait for a short period of time to collect their feedback, and then predict the importance label for the remaining users based on the collected feedback. This actually is an active learning problem, which we investigated in our recent paper published in KDD2016. In spite of the user feedback obtained from active learning, the feedback data is still limited. For instance, it cannot well handle new users of a mailing list or new mailing lists. These cases are very common in the real world. To address these problems, in our KDD16 paper, we propose a new cross-domain recommendation framework. Cross-domain recommendation is an approach trying to transfer actual information from source domains to a target domain. For instance, when we recommend movies, we can improve the recommendations in the movie target domain by transferring knowledge of user preference from book source domain. If a user likes science fiction books, he is very likely to also enjoy science fiction movies. In our scenario, we treat each mailing list as a domain. Most previous cross-domain recommendation methods consider a relatively small set of domains, like 2 or 3 domains, and the selection of source domains is usually done manually based on expert intuition. For instance, books intuitively make a good source domain for movies because they can share similar size of categories. However, there are millions of domains in an email system. There is no way to rely on intuition or a human expert to select the optimal set of source domains for each target domain. In our paper, we propose the first cross-domain recommendation method that can select the optimal set of source domains automatically, considering multiple criteria. Want to know how we did it? Please refer to our paper with the following link or scan the QR code with your phone. Thank you very much.